In this video, we're going to continue to look at how we name compounds. And we're going to start with molecular compounds. So, what if you're working with a molecular compound? The way you name it, it's shown in this table, where you have the name of the first element and you have a prefix in front of that element, where the prefix is the number of atoms present in that molecule. Then your second element is named and it's given "ide" because it's a non-metal, just like we learned for the ionic compounds. And it also gets a prefix. So let's take a look at some examples. Nitrogen triiodide. Usually, when you look at elements, although there's only one, you don't have to call it mono if it's the first element. So it wouldn't be mononitrogen triiodide, even though that's correct. Although if it was only one iodide, then it could be nitrogen monoiodide. So just something to keep in mind. If you do put mononitrogen triiodide, that is technically correct. Let's look at another example. PCl5, or phosphorus pentachloride, or P4S10, tetraphosphorus decasulfide. So the strategy is just you name the first element, and you count how many subscript numerals there are. So here's a 4, and you look up the prefix. Then for the second element, you name it but add "ide," and you add the prefix of how many atoms there are in that compound as well. Now for acids, the naming scheme is a little different. And what an acid is it's a compound that releases hydrogens into water. So for example, hydrochloric acid, HCl, breaks down into H plus and Cl minus. You notice I have this little AQ symbol next to my elements. That means they're aqueous or dissolved in water. And we have acids in our everyday products such as vinegar, cleaning Lysol, and soda all have acids in them. And acids dissolve metal and they are generally sour tasting. So think of lemons or vomit, very sour tasting. Now we have two different types of acids that we're really going to look at to begin with. So acids generally start with a hydrogen in front of the naming system. Not always, but generally. So hydrochloric acid has a hydrogen out in front. That's how you know it's an acid. And then we have two different types of acid. We have a binary acid, such as hydrochloric acid, where you only have two types of elements. Or you have oxyacids, where your acid contains an oxygen. We'll talk about oxyacids in a bit, but let's focus on binary acids. The way you name binary acids are shown here. You use hydro, then the name of the nonmetal plus an ic and an acid. So here, that's why it's hydrochloric acid, because it's chlorine, but we change that nonmetal to an ic to be hydrochloric acid. How about oxyacids? Well, an oxyacid contains hydrogen and an oxyanion. An oxyanion is just an anion, remember, negatively charged ion, containing a nonmetal and an oxygen. So let's look at our polyatomic ions as well. So carbonate would be an oxyanion. Chlorate, oxyanion. So you're just looking for a nonmetal plus an oxygen. Now, how do we name oxyacids? Well, honestly, it is a little confusing, but you just have to memorize two things. So let's look at our polyatomic acid name. If your polyatomic acid name ends in an 8, such as nitrate, chromate, sulfate, phosphate, you change the name of the oxyanion to be ic, and you add the word acid, such as sulfuric acid. You have two hydrogens in front, so you know it's an acid. Your polyatomic ions, SO4, so it's sulfate. Since it's sulfate, it's sulfuric acid. Same thing as nitric acid, where you have NO3 for nitrate, so it becomes nitric acid. Now, if your polyatomic ion ends in ite, such as nitrite, sulfite, then you change the name to ose acid, so nitrose acid or sulfurose acid. And again, all your acids have this hydrogen out in front. And here's the flow chart for all the naming schemes we have covered in the last few videos. In this video for ionic metal and nonmetal, molecular, which are nonmetal elements only, and acids, hydrogen plus one or more non-metal. So you're going to want to learn how to use this flow chart, and this will greatly help you in naming all your elements. And so let's try and do some practice. Now, I have 5 different compounds for you. I want you to pause the video and go back to the flow chart if you need to, and try to figure out the name for all of these compounds. So start the video again once you have an answer. Alright, let's take a look at these. So our first is silicon tetrachloride. 1 silicon, 4 chloride, silicon tetrachloride. Next we have tetranitrogen tetraselenide. So nitrogen 4, selenium 4, so it becomes selenide. Phosphorus trichloride. So 1 phosphorus, 3 chlorines. We have an H in front, so it's an acid, and NO3 is nitric acid. Now here's a binary acid, HF, so it'll be hydrofluoric acid. So if that confused you or if you got it wrong, watch the video again, look at the flow chart, and do more examples. But that is how we name elements. And that's all for this video. See you in the next.